we have new model, multimodal R4B. R4B is a billion parameter multimodal large language model designed to be both powerful and efficient. Its key innovation is an auto-thinking capability, which allows the model to automatically decide whether to use a complex step-by-step reasoning process, thinking, or give it a direct, concise answer, non-thinking, based on the difficulty of the user's query. To achieve this, they use a process that involves two steps: bi-mode annealing and bi-mode policy optimization. Bi-mode annealing, teaching the model how to think and not think. The first goal is to create a base model, R4B base, that is proficient in both thinking and non-thinking modes across a wide range of topics. They needed a massive dataset with examples correctly labeled as either requiring reasoning or not requiring reasoning. Creating this manually is impossible. Instead, they developed a clever automated strategy. They used a very powerful existing model, Qwen 2.5 32B VL, as an automated annotator. For objective questions like math, they used offline hard mining. If the powerful model failed to answer a question correctly multiple times, the question was labeled hard and assigned to the thinking dataset. If it answered easily, it was labeled easy and assigned to the non-thinking dataset. For subjective questions like describe this image, they use prompt engineering to have the model judge the complexity of the query. So they just judge it with prompt engineering. Training protocol. The model was trained on this mixed dataset, thinking samples, formatted as a think, detailed reasoning steps, and then close think tags and final answer. And non-thinking samples, they just have this think and close think in the beginning without anything in between, and then final answer. The tags are present but empty, teaching the model the structure for a direct response. So the stage 1 produced the R4B base, and it was capable of performing both modes, but it was biased towards not using thinking. So they call this thinking entropy. Then stage 2, bi-mode policy optimization, teaching the model when to think. The problem with startup reinforcement learning is if you just reward correct answer, then model would always use thinking because it would just use more compute to get the correct answer. So they use this bi-mode rollout. So this is the trick. For each input query during training, the model is forced to generate two separate responses, one in thinking mode and one in non-thinking mode. Both responses are then evaluated by the reward model. They noted in paper that they just needed a simple rule-based reward function for mathematical domain, and this surprisingly generalized well to other areas. The model's internal policy is then updated to favor the mode that led to a higher reward for that type of question. We see here it outperforms Qwen 2.5 VL 7 billion parameters, outperforms some other models as well. Here you see how only thinking mode has a lot more tokens than this auto thinking. And so this is deciding if it should use fewer tokens, just like the non-thinking mode, if it's easy, or use more tokens like thinking mode, if the questions are hard. That will be it for this video. Check out other videos on my channel and see you next time.